The radius of curvature at the origin. Suppose we are given a curve y equal to fx. Then we can expand it using Maclaurin's theorem. So we write it f0 plus x f dash 0 plus x square by factorial to f double dash 0 and so on. Now, here, since the curve passes through origin, so if we put x equal to 0, y equal to 0, so we will get f0 equal to 0. So the equation of curve will become, first term will become 0, and then we can write it, suppose this we write as this thing as p. So it will become y equals px and this thing as q. So this will become q times x squared by factorial 2 plus next third derivative x cubed by factorial 3 times f triple dash 0. So if we write this as r, so r times x cubed by factorial 3 and so on. So here, as I told you, f dash 0 is equal to p, f double dash 0 is equal to q. Similarly, f triple dash 0 equal to r and so on. Now, if we differentiate this equation, so we will get y1. So y1 equal to p plus q times 2x upon factorial 2 plus 3 times r times x square upon factorial 3 and so on. Now, if we differentiate it again, so we can get y2. So this term will become 0 and this will become 2q divided by factorial 2 plus 6rx upon factorial 3 and so on. Now, at the origin means 0, 0, we have got y1 equal to p. Here we are putting x equal to 0 and y2 will be equal to this term because x will be 0. So 2q upon 2, that is just q. Now, the radius of curvature rho is given by 1 plus y1 square whole power 3 by 2 divided by y2. So we put these values. So we will get 1 plus p square power 3 by 2 divided by q. Now, let's understand this concept by taking some examples. So, question number 1. Find the radius of curvature at the origin of the curve x square plus 6y square plus 2x minus y equal to 0. So, let's write it here. So, x square plus 6y square plus 2x minus y equal to 0. And the tangent at the origin can be found by equating the lowest degree term to 0. So here lowest degree term is this. So 2x minus y equal to 0 is the tangent. Now here we have to put y equal to px plus q times x square upon factorial 2 plus r x cubed by factorial 3 and so on. So if we put this value of y here, so we will get x square plus 6 times px plus 2 times x square upon factorial 2. So dot 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 whole square plus r times x cube upon factorial 3 and so on. So, sorry, here I missed it. So, we have put the value of y as px plus q times x square upon factorial 2 dot dot whole square plus 2x. So, 2x minus y. Y is this term itself. So px plus q times x square upon factorial 2 plus r times x cube by factorial 3 and so on equal to 0. Now, what we do, we find the terms containing x, means coefficient of x, x square, x cube, etc. And they will be equated from both the sides. Since in RHS it is 0, it means they will be 0. So coefficient of x. So here coefficient of x is 6 times p. Sorry, not 6 times p. Coefficient of x will be from here. This is x because here this will get squared. So it will be x squared. So this is 2 and p only. Other terms contains higher power of x. So we can say coefficient of x will be 2 minus p equal to 0 because in our just it is equal to 0. So from here we get p equal to 2. Now we find the coefficient of x square. So here it will be 1. And here coefficient of x square. So this will be p square, 6 times p square. And from here, coefficient of x square will be equal to minus q upon factorial 2. And this will be equal to 0, but p equal to 2. So if we write it here, 1 plus 6 into 4 minus q by 2 equal to 0. So we will get 2 plus 48 minus q equal to 0, from where we will get q equal to 50. So we have got the values of p and q, and you know that radius of curvature is given by 1 plus p square power 3 by 2 divided by q. So on putting the values, so 1 plus p is 2, so 2 square, that is 4, whole power 3 by 2 divided by q is 50. So it will become 5 power 3 by 2 divided by 50. This can be further simplified. 5 root 5 divided by 50. So this will become 5 will cancel out, root 5 divided by 10. And further, we can simplify it. So this will become 1 upon 2 root 5. So that is our answer. Now let's consider one more question. Find the radius of curvature at the origin of the two branches of the curve given by x equal to 1 minus t square and y equal to t minus t cube. So here x equal to 1 minus t square and y equal to t minus t cube. So let's reconsider it. X equal to 1 minus t square and y equal to t common 1 minus t square. And in place of 1 minus t square, we can write x. So we get y equal to tx or t equal to y upon x. So here this will become x equal to 1 minus y square upon x square, which can be further simplified. So it will become x cube minus, so let's write equal to x square minus y square. So we can write it x cube minus x square plus y square equal to 0. And since if we put lowest term equal to 0, so we will get the tangent, and it is clear that it passes through the origin because when we put x equal to 0 and y equal to 0, we will get 0, 0. So equating lowest term to 0 to get tangent, so we will get y square equal to x square, or we can say minus x square plus y square equal to 0. So the two tangents will be y equal to plus minus x. Now, again, proceeding in the same way, we can write y equal to px plus qx square upon factorial 2 plus r x cube by factorial 3 and so on. So this value we will put in this equation, x cube minus x square plus y square equal to 0. So what do we get? We will get, let's write it here, x cube minus x square plus px plus qx square upon factorial 2 plus r x cube upon factorial 3 dot 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 equal to 0. Now we try to equate the coefficient of x square and x cube from both the sides, and RHS they are 0, so they will here. So it will become coefficient of x square. It will be minus 1 here, and x square here. It will be equal to, it is y square. So here, so coefficient of x square when gets squared, so it will be p square. So plus p square equal to 0, from where we will get p equal to plus minus 1, and coefficient of x cube. So coefficient of x cube will be 1 from here, and this will become power 2, this will become power 4. But when we multiply, like a plus b plus c, etc. whole square, if you remember, a plus b plus c whole square, so it becomes a square plus b square plus c square plus 2ab plus 2bc plus 2ca, etc. So here, not only 3 terms are there are many terms, but suppose we consider first 3 terms. So product of these 2 terms, when we write twice of AB, then we will get x cube terms. So we can say coefficient of x cube will be 1 from here, and this will become 2AB. So A will be P, and B will be Q upon factorial 2. And this will be equated to 0. So we will cancel out 1 plus PQ equal to 0. So there are 2 possibilities. When P equal to 1, then Q will be -1. So let's write it here. When P equal to 1, then from here Q will be -1, and when P equal to -1, Q equal to 1. So radius of curvature will be rho equal to 1 plus p square whole power 3 by 2 divided by q. So we put the values. So this will become 1 plus 1 whole power 3 by 2 divided by, let's write the value of q directly as plus minus 1. So plus minus 1. So this will become 2 power 3 by 2, which means 2 root 2 divided by plus minus 1, which is plus minus 2 root 2. And that is our answer. Thank you for watching.